Hello everyone and welcome back. Today I'm excited to show you my latest project, version 3 of my electronic load. This time I built it with SMD components, a sleek 3D printed case using marble PLA filament, and a 1.8-inch TFT display. Let's take a closer look. At the front, we have banana plugs for connecting the load, an on-off button, and LED indicators, blue for negative, red for positive, and green for the load state. On the back, there's the main switch and the 12 volts power input. Let's test it. I'm connecting a power supply, setting it to 12 volts, and turning on the load. The display shows the current, and as I increase it, we can see that the readings match on both the power supply and the load. Now, I'll push it beyond 2 amps. And there it is, overcurrent protection is activated. Next, I'll test overvoltage protection. Increasing the voltage beyond 24 volts, the protection kicks in, cutting off the load. Time for the thermal protection test. Running at 12 volts and 1.83 amps, I let the temperature rise. To speed things up, I increased the voltage to 15 volts, generating more heat. At 45 degrees Celsius, the cooling fan automatically turns on. Now at 20 volts, we're hitting 36 watts of power. And at 60 degrees Celsius, the thermal protection activates, shutting the load off. As it cools down, the fan turns off at 35 degrees Celsius. Before we go further, a quick shout out to today's sponsor. A big thanks to PCBWay for sponsoring today's video. If you're into electronics, prototyping, or DIY projects, PCBWay is the perfect partner to bring your ideas to life. They specialize in high-quality PCB manufacturing, 3D printing, and CNC machining, offering everything from simple single-layer boards to complex multi-layer and flexible PCBs. Ordering is super simple. Just upload your Gerber files, customize your board specifications, and get an instant price quote. Did I mention their pricing is incredibly affordable? You can get 5 high-quality 2-layer PCBs for just $5 with fast turnaround times. And if you're short on time, they even offer assembly services so you can receive a fully assembled board ready to use. Now let's take it apart. I'm unscrewing the case, removing the heatsink cover, and taking out the bracket holding the cooling fan. And here's a close-up of the fan mount. Looking at the main control board, we have the ATmega328, INA219 Current Sensor, LM358 Operational Amplifier, Mini 360 Buck Converter, 5 volts and 3.3 volts regulators, fuse and diode protection, relay, trim pot for temperature adjustment, and connectors for the adjustment potentiometer, temperature sensor, and cooling fan. Moving to the back, we see the power MOSFETs, temperature sensor, and power resistors mounted on the heatsink. and the front panel holds the display, LEDs, button, banana plugs, and adjustment potentiometer. Now, let's talk about the case itself. The marble PLA filament makes it look fantastic. Huge thanks to Sunlu for providing the filament. They sent me a few spools of filament to test, such as rainbow filament, dual-color silk filament, purple, and the marble one that I used for this project. You'll probably see me using the other filaments in my future projects. Let's put everything back together. Reattaching the bracket, inserting the main board into the case, mounting the front and back panels, securing the heatsink, and screwing everything back in place. And there you have it, my electronic load version 3, a compact, feature-packed design with protection systems and a beautiful 3D printed case. Let me know what you think in the comments. If you enjoyed this project, don't forget to like, subscribe, and stay tuned for more builds. As a final thought, I want to take a moment to thank everyone who supports me and my channel, both my subscribers and those discovering my content for the first time. Your support truly means a lot. If anyone wants to support my work and help me keep creating, You can do so through Patreon or directly via PayPal. Any support is greatly appreciated. And finally, I just want to say, good luck to you all.